Okay, we're ready to go. Before we get started with the lecture, a couple of questions real quick. First, was anyone unable to access the video that I released for our last session? Everybody was good? Capable of looking at it? Okay, cool. Do you have any question about it before we get started? So far, so good? All right. Okay. So we are going to start as usual with a few announcements. We are transitioning into our first, I would call it our first real module. Okay, module 0 was really review time, like let's all get at the same level so that we can get started in the same condition. Okay, so we are not yet done with it because we have the IE0 coming up Monday, right? But as soon as the IE0 is gone, as soon as it's graded, that's it. We are totally done with module 0. So in the meantime, we're not going to sit and wait for this to be over. We are going to get started with module 1. And module 1 will be the introduction to object-oriented programming concepts. So again, depending on who you had, for COP2512, some people like to actually introduce some of those object-oriented programming concepts early on. So you might already be familiar with this. So remember the curve of difficulty that I mentioned for the course. We're just starting to ramp up a little bit, but it's still nice, okay? The treadmill is mostly horizontal yet. We're not going to sweat too hard. But we are starting with the topics that are going to be our major concern for this entire semester. For every module, from now on, we are going to have mandatory reading assignment. So I stress that out because for module 0, it was pretty much pick and choose, okay? And by the way, I got a decent amount of questions, not as many as I wanted during office hours regarding the review, but that's okay. That probably means that most of you are okay with the review material, which is good. But some of the questions, I want to share something with you. Some of the questions revealed that the reading assignment were kind of skipped over or something like that, okay? It's fine as long as you know the stuff, right? Like you don't have to reread the chapter on method if you remember everything about method, or if you already took the class with the same textbook or stuff like that. But in doubt, please make sure that you check out those chapters, okay? So those 8 chapters that we had for module 0, they were really optional. It was depending on a la carte, what you need, go ahead and read a little bit. Some people came to me to office hours, I redirected them to some of the chapter, perfect. From now on, they are going to be mandatory because the lecture is going to try to detangle what is generally the most problematic for people, okay? And then the reading assignment is going to add a second layer on top of that. I already mentioned that our first lecture, right? So it's going to add a layer of details, a layer of things that are catalog in nature, reference in nature. For example, I might mention 5 different methods that work on strings, okay? But there's a catalog of maybe 30, 20 of them. The other ones, if you understand the first 5, are going to be simple. So instead of spending the class time going over all 30 of them, I'm going to illustrate the ones that are a little bit more challenging, and then I'm going to ask you to read the textbook to fill in the blanks here regarding those other methods that exist. And as usual, all of this is fair game for posting question on Piazza. All of this is fair game for coming to the next lecture and asking me at the beginning of the lecture, I have a question about what we were covering, last week, etc. Just don't stay isolated. Work in a study group, do this kind of stuff. This is going to make your learning experience much more enjoyable and productive. So for this module, the chapter that we are going to use is chapter 9, objects and classes. Okay. Here's an overview of the topics we are going to cover. So it's a very, very high level overview. I'm getting tangled in my lapel Mac here. It's a very high level overview. During this session, we should be able to cover the first 3 items, maybe get a little head start on the 4th. So it's going to take us about, I would say, 3 sessions to go through that module. Okay, something like that. So the first 2 items, they kind of collapse together, and it's going to be really an easy deal. It's going to be just a few minutes, remarks, general common sense knowledge there. We want to motivate pretty much the need for object-oriented programming techniques. Okay, we're not going to spend a lot of time arguing whether object-oriented programming is the best style or the worst style or anything like that. We're not going to do that kind of comparative stuff. But I just want you to have an idea of why it came to be and why it's still so much used today. Okay, there is an intrinsic appeal to object-oriented programming for some categories of problem. Again, if you try to apply the wrong tool to the problem that you're trying to solve, then there's no redemption in that. Okay. Then we're going to talk about classes and objects. So I already started that. That's something that you're going to notice in my lecturing style. I always mention things in passing. At the beginning, it's really informal. It's just a little remark here and there. And then the next session, I kind of insist a little bit. And then what do you know? 2 sessions after, we are formally introducing the concepts. And then we keep referring back to it, okay? So it's kind of like instead of just introducing things one time and then we're done, we ramp up to it again and then keep using it as much as we can. So I did that for classes and objects a lot. For constructors, just a little bit, okay? I think I mentioned them like a few times. So some of you, again, depending on how you took COP2513, you know already what is a constructor, what a class, what is an object. Perfect. For the others, don't worry, we're going to round up like the terminology here. And this is where we should be able to stop either at the end of the session, probably not cover entirely constructors, but at least classes and objects and the motivation part. And then we're going to talk about some topics that, again, some of them were already introduced. The des keyword, des is a keyword in Java. I didn't mention it at all. It's something that is common to every object-oriented programming language. At least every object-oriented programming language that I know of has an equivalent keyword. For those of you who took Python, maybe you use the keyword self, if you remember. That's exactly the same thing. Des in Java, self in Python. This is a way for a method, for a piece of code, to reference, to find out what object is being applied to. So in your code, when you write things such as scanner S equal new scanner system.in, so you create a new scanner referenced by the variable S, and then you do s.nextInt. So what you're doing really is you're calling the nextInt method on the scanner object that is being referenced to by the variable S. Okay? See how that works? S.nextInt. Okay, so that nextInt method, you wrote the code once in the class scanner. I mean, we didn't, but people at Oracle did. And it has to work with any object that we create at any time of type scanner. And it has to figure out which scanner it's working with. For example, one scanner is plugged into the keyboard. Another scanner is plugged into a text file. A third one is plugged into a URL. So this is where they are going to read their data from, okay? When you call nextInt, it's supposed to be the same code running, but in what context? Which of those 3 objects are you running it to? Are you running it in the context of? So this keyword allows you inside the code, when you write the code for those methods, to say, well, I can check what's happening in my object. Des.something, and I can call method, des.something, and I can check, values of particular data fields. Immutability, that one we already mentioned briefly again, very, very briefly. Immutability, it's still related to classes and objects. These are classes and objects that cannot change. When did we first encounter, it's really recent, when did we first encounter that word, immutability? Anybody remembers? Yeah?
You're saying like strings can't get broken apart?
Yeah.
They're made like
Perfect. So, like the last lecture, the one that was posted as a video, right? We were talking about trying to swap things, and we ended up playing with arrays, and we were trying to swap the reference to array. It didn't work that well. Then we were trying to swap the element inside the array. That worked well. So that was, the big deal was, okay, now we can use the references to swap actually things inside of a method. And then there was the last slide that said, well, why don't you try that with strings? And I kind of spoiled it for you, but I wanted you to have the answer already. The deal is that it's not going to work with strings because arrays, you have the tools to go inside an array and change something in one of the cells of the array. But strings, once the string is created, the individual character cannot be changed. You don't have any method in the string class that allows you to do that. End of story. We say that the string class is immutable. And it's a very important concept. This is a concept that is getting even more important as time passes. People are realizing that having immutable things in your code, sometimes it's a good idea. Okay, this is an idea that comes back from the 60s. from functional programming, okay, where almost everything is immutable, right? And object-oriented programmers start to realize that, okay, maybe I like my object-oriented programming style. I don't want to go completely functional, but that idea of immutability, yeah, if it cannot change, I cannot bug it pretty much. So it's kind of like a safety in your code. Then we're going to talk a little bit about JDK classes, so just like catalog type of stuff. Object as parameter, we already started messing around with that when we did the swap method, okay? So I'm going to put the lead on it. We're going to finish up that topic. And then we're going to talk about instance versus static anything. So anything meaning method and attribute. I'm going to define this, okay? So for now, I'm not going to say much more about this one, but you know that static keyword that we have been using all over the place for all of our method. Every single one of our method was a static method until now. Well, we are going to finally finish that. And finishing that topic means that the first few lines that I ask you to write since the beginning of COP2513 in every one of your Java program, finally, those first few lines, you know, that declare a class and that declare a main method, they are going to hold no longer any secret. The static keyword was really the last thing that we needed to, actually two things, static and public. Public is easy, static has a little bit more depth to it. So once we do that one, you're going to be 99.99% there. All right. So one more thing regarding the logistic of the modules, since this is our first real module. The PQ is released today. Okay, so same ID than PQ0. Every time you open it, you get 5 or 10 random questions from a bank. All right, practice a lot with it. Don't wait. Start with this lecture. At the end of this lecture, between now and the next lecture, open up the PQ. Of course, some of the questions are going to be on stuff we didn't cover, but they are going to be easy to spot. Right? They're going to talk gibberish about stuff that you never heard of. So skip those. Try to answer the ones that are on what we covered, and then reopen the quiz, play a little bit with it. This is useful for the lecture. It's most useful for the reading assignment because it really drills into details. And of course, at the end of the module, I will remind you of the deadline and stuff like that, but at the end of the module, we are going to have a GQ, a graded quiz, that's going to give you a self-evaluation pretty much of whether you missed important stuff in the reading assignment or lecture. So it's a good idea to work progressively on that. The practice exercise. So, like I already mentioned, in this class, in this course, we're not going to use coding bat because it really doesn't have anything for object-oriented programming practice. It's really great for COP2512. So is the Pearson MyLab, you know, that comes with the textbook. But for object-oriented, both of them pretty much fall short. So instead, we're going to rely mostly on the exercises in the textbook. So I'm going to give you a list every time. A selected exercise doesn't mean that you have to do only those, but I really encourage you to do at least those 5 exercises, okay? During module 0, again, it was pick and choose. During the other modules, if I give you a list of 5 exercises like this one, I really encourage you to try them all, okay? And I try to select them so that they are increasing in difficulty or at least cover different, you know, aspects that might be challenging. For example, here, the first one, the stock class, is going to be like very, very similar to what we do as examples in the lecture. Okay? If you understand the lecture, you can almost cut and paste from your brain into that exercise. You are going to get to the end and have it successfully work. Then use the date class and use the random class. Different topic. So not more difficult or not easier, but different. Okay, so we are going to try to, as a side topic in this module, we are going to try to learn to use some of the common classes that you are going to need sooner or later in the JDK. So date and random, yes, these are probably the most 2 important ones that I mentioned in the reading assignment. So let's put some practice on those. Account class, fan class, these are the ones that are meant to look like an IE. So I could take actually the account class exercise or the fan class exercise and maybe shuffle them a little bit around, move them around, like change them, and adapt them to be an IE, whatever the number will be when we release it. Okay? So we're going to try to have an intermediary exam every 2 weeks. That's why I'm saying, you know, at the end of every lecture, do a few practice quiz. Stay up to date, you know, and that will make your life easier. And start working on the exercise as soon as we cover the stuff that you need to do then. For example, that stock class even if we go a little slow today, you'll still have, I would say, 80 to 90% of the knowledge to be able to finish it up. So why not try that? Even if you have to ask a few questions or look up some stuff, that's actually good. It's active learning. It's going to make you think, okay? And then next lecture, when you come, you'll have questions to ask during the lecture, okay? So I'm just like reminding you of pretty much the pace here, because module 0 was really different. So now we are going to adopt this kind of strategy, and it's going to be the same thing for every single one of the module until the end of the semester. So we are going to settle now in a regular learning routine with the same learning activities, same pace, etc. As much as I can, I will try to make everything, with a stable, regular pace. All right. So, yes.
Sorry, will there be any graded exercises or the new type of exercises for this module?
So the graded stuff is going to be the GQ and the IE. Okay. The reason for which the practice exercises are not graded is because, like the current working hypothesis that I have with a few colleagues, is that we get more bang for the buck when we allow you to work together, or even to Google stuff to a lesser extent. Okay, I don't encourage you to Google, but my point is that if I give you total freedom to work on those exercises, then every one of you is going to actively get involved in the exercise and try to solve them one way or the other. And then after that, we have the safety net of the office hours, right? Whereas if we grade stuff, then we have to be a lot more stringent. So you can still get feedback on those practice exercises. That's a very good question, actually. You should not think that the practice exercises are, here, take your exercise, go home, I don't want to see you until next lecture. No, it's just a conversation starter. These things are there to sometimes challenge you a little bit. At the very least, make sure that you can apply whatever we have been talking about during the class, but you're not alone with those. So if you need feedback, you are not going to get a grade, but you're going to get somebody, me or one of the TA, that looks over your shoulder, okay, online, and looks at your code and say, you could do this better. What about this and that? So you can get full feedback. Please use the office hours. My TAs right now are bored. They don't have enough people asking them questions. We have, I would say, maybe 10% of the class coming to office hours. So it's okay. As long as it's easy, you don't need them, go for it. But for practice exercise now, yeah, it's a good idea to bring your practice exercise. Just take a look. Tell me if I did something right or wrong there. Okay? All right. So now we're going to switch to the transition between 2512 and 2513. Well, we're still technically started doing that because we have been doing a review on the essentials for COP 2512. So what do I mean by emphasizing the link between them? We are transitioning from one style of programming to a different style of programming. And I want to emphasize the differences, okay? The style of programming that we used in COP 2512 was what I would refer to as procedural programming. A procedure, a routine, a method, a function. They are slightly different, okay, but they capture the idea of what we learn to do and what you learn to do in whatever class you took for COP 2512 when you write your first function, when you write your first method, okay? You package a unit of code. It has parameters. It may or may not return a value, okay? You call that unit of code. You give it data. These are the argument. The unit of code does something and may or may not return a value, but may also display something on the screen, open a file, whatever, okay? So that concept of a unit of code that is a procedure, that is a method, that is a function, this is central to this style of programming. So the goal of this style of programming is just, no matter what problem you throw at me, I'm going to break it down into the tool that I have, which is procedures, function, method, stuff like that. I'm going to break it down into smaller chunks, and then I'm going to solve each chunk at a time, test them independently, test them together, and move on like that. So the way we did that in Java, we simplified things. We said, okay, every program that I ask you to write, every app that I ask you to write, is going to fit in one source file. And every source file that you have in Java is going to have inside of it the declaration of one public class. And we are going to stretch a little bit those rules this semester. We're going to go a little beyond that, but the essence of it is still correct, okay? You can have only one public class per .java file. You may have other classes that are non-public inside of the file, but we haven't covered exactly the keyword publics yet, so far we haven't tried that. So we had a very simple scheme where every program was its own file, every program was a single class, and then inside that class we had the main method. And that's it. At the very beginning, that's all we had. We didn't even have procedure. So that was pretty much procedural programming with one method, and the method is the main. And what we did is we wrote the code inside the main method, and that's it. There was zero reusability in that kind of stuff, okay? So what we are going to do is we are going to grab JGrasp. There we go. And we are going to do something very simple, very stupid, a hello world again, once again. This is the last time we do a hello world, I promise you. But we're going to do a hello world real quick, and we're going to do it with that style. Then we are going to transition to the next style, then the next style, and finally end up with object-oriented programming. So I have my boilerplate code here. I'm going to need a scanner at some point. So I'm going to import java.util.scanner here. All right. I'm going to save the file with actually its correct name. Thought I already did that, apparently not. There we go. It's compiling, good news. So we want to do a hello world. So we are going to do like a little program that does just a greeting to the user. So scanner s equal new scanner. What do I need a scanner? Because I'm going to ask the user to give me their name, and I'm going to personalize the greeting. So scanner s equal new scanner of system.in. So a lot of things happen in that line. 4 steps, actually. We're going to detail them each when we start doing constructors, okay? But pretty much, construct a scanner object, put the reference in the variable s. And then there are a few more details that we're going to cover very soon. And then once I have this, I can do system.out.println. What's your name? And then I can do s.next and store that inside a variable named name of data type string. Okay? And then I'm going to compile that to make sure it's syntax correct. And then I'm going to do system.out.println, and my greeting will be hello followed by the name. Something very simple. Okay? So we did that like first or second session of COP2512, nothing to it. But now look at it in the context of the programming style that I mentioned, okay? One file, one class, one method. So we cannot really scale up much with that. We cannot even exchange code, really. The only thing I can say is that if you are like desperate and you need an example of hello world from me, I can say, well, here's my file. But we cannot really meaningfully exchange sub-part of our code that you and I are working on. It's all monolithic. It's all one block. This thing, this huge thing here, that's a small thing actually, but this thing here solves one problem, and that's it. There's no way to break it down and reuse parts of it. Okay, so if I run that, of course, what's your name? John, and let's try like this. John Smith. Hello, John. So I'm going to make this a little bigger so that you can see. So first, before we move forward, what's wrong here? What did I mess up? Yeah? Yeah, I completely ignored it. So what's happening exactly? Well, let's add a layer to what we already mentioned about that kind of problem. What if I do string name and then string last name equal s dot next, and then I do here a system.out.println, so I'm being lazy here, but in my defense JGrasp doesn't autocomplete, so I have to do it a different way, and I'm going to say here, oh, I almost forgot, and there last name. So what's happening here is I read the name, the first name actually, but I'm going to revert back to the full name, so I'm not changing the name of that variable right now. I read the first name, I display my little greeting, okay, and then I read the last name, and I display, oh, I almost forgot, and the last name that I read. All right, let's run this. I just want to draw your attention to a weird, not a weird, but a particularity of doing I/O with scanners in Java. If I run this, I'm going to type John. And the way that my code is written, you would expect, that I hit enter. Hello, John. Now it's waiting for the last name. I'm going to type Smith. Oh, I almost forgot Smith. And that's exactly what we were expecting based on what we've seen so far. Let's run it again. John Smith. And now it reads John. So I hit the enter key only once this time, right? Type John Smith, enter. It reads John. This is what this call to next is getting. And then I display hello John. And then it reads again from the keyboard the next word that has been typed. And it's still there. So there is a concept that's going to make your life a lot easier when you debug these kind of little programs that do some input-output, either to files, text files, for example, or to the console with a keyboard and stuff like that. It's the concept of an input buffer. All right? So there is, when I hit enter, everything that I typed gets sent into a buffer. It's stored. So John space Smith. Okay? So when you call s.next, you're not reading everything up to the enter key that I pressed. What you are doing is you are going to the input buffer and you say, what do you have for me? If there's nothing in the input buffer, then my program stops. My program waits that I type something and that I enter it so that there is now some data in the input buffer. As soon as there is enough data in the input buffer, the s.next method call is going to look at what's at the beginning and say, well, I need to read the next word. So you type J-O-H-N space. Space is a separator. It's considered a white space, right? So that means that this is the end of a word. So that's it. J-O-H-N is what I'm going to grab out of the input buffer. And I would have to double check, but I think it grabs also that extra space, but discards it. Okay? Now I read John from the input buffer. This is what I return to you. The next time you call s.next, same logic. If the input buffer is actually empty, I'm going to wait for you to type something and follow it up with enter, which is going to result in putting some data in the input buffer. If there is already something in the input buffer, something left over, for example, then I'm going to use that. So what did we have left over? Well, I typed John space Smith. So we took away the John. Okay, we read it. It's been processed. The space has been discarded. Now we are left with Smith and then enter. So this is what the second call to next int is going to read and return to you. So you can actually use enter after every piece of data, or you can just separate them with spaces or whatnot, and then hit enter at the end. And your next calls are going to read always whatever is next. That's why it's called the next method, right? Whatever is next available in the input buffer. Of course, one of the things that we mentioned really quick in passing is that sometimes you don't want that. Sometimes you want to read the whole thing in one shot. So I'm going to go back here and I'm going to say, you know what? Forget about that first name, last name, mumbo jumbo. What's your name? I want to read the whole line. So now if I say next line, it's still the same logic. When I call the method next line, if there is nothing in the buffer, the program is going to pause, it's going to wait for me to type, and when I hit enter, the data is put in the buffer and the method can then proceed. Okay? But if there is something, it's going to read everything, but it's not going to stop at the first space or tabulation it encounters. It's going to read everything up to the very end, up to the point where it finds pretty much a character that corresponds to the enter key that I pressed. It's going to discard it, but it's going to give me everything else that was read on the entire line. Hence the name of the method. Okay? So a little bit more detail, but that layer thing that I like to do, that 7-layer burrito, well, this is layer number 2. There are 5 more. Now, for that topic, I think we're good, but the idea is the same. All right. So this is pretty much anything I can think of to tell you about that system. Back to the big picture. All right, we have this unit of code that does its job well, hopefully, John Smith. There we go, hello, John Smith. And it's absolutely atomic, in a way. I cannot separate it in smaller chunks. All right, so back to what we were talking about. while we were actually writing only one method like that in our code, we still took the liberty of calling a bunch of other methods, except that those methods were already written for us. For example, the scanner nextInt, okay, yes, we use that. System.out.println, that's a call to a method. Math.random, let me move this thing on the side here. Math.random to generate a random number. Yeah, we use those methods. So it's not because you restrict yourself to actually have one file, one class, and one method named main that you cannot already start using method. It's just that these are methods that have been written by other people. That's it. Okay? So the only thing that I didn't explain in this slide coding is that line. Int value equal new scanner system.in.nextInt. So I'm not going to use an int value, but I'm going to use my name here, and I'm going to try to apply the same thing. So let me package this differently. I'm going to declare the scanner after I display the message so that I can comment those two lines. Okay. And then I'm going to use the trick that was on the slide. String name equal. So this time, I still do a next line. Okay. But I apply the method next line to an object that I'm going to create on the fly. So create an object on the fly, new scanner system.in. That's what this one-liner does for us, okay? So it does a lot of stuff in one line. It creates a new scanner object, that's a new scanner bit, connects it to the keyboard, that's the system.in bit. And then this returns the value, right? This part here, new scanner system in, that returns a value. What do I do with it? Well, I used to take this value here and shove it into a variable so that I could then use the variable to access the scanner and tell it to do some work for me. Okay? Now, this value here is not assigned to any variable. Okay? I just get the value of the new scanner, pretty much a reference to the new scanner. I'm going to use it immediately. And I don't even save the reference to the scanner. I let it kind of dangle in the void, right? Meaning that I'm not going to use it ever again. I don't care about saving it. I don't care about having a variable to access it again in the future. All I want to do is right there, right now, I want to call the next line method on that reference value that was returned. That's it. Create the object, get a reference to the new object, call the method next line on that reference, so talk to that object and tell it, go do your job, read me an entire line from the console, and then what does next line return? Well, the same thing it used to return before. It returns a string that represents everything that was typed before using the enter key, and I still put that in the name variable. So if I compile, run this, John Smith, there we go, it's still working exactly the same way. Okay? So there are two levels, right? There are two levels related to syntax, related to knowing your tools. The first level is you are capable to get the task done. Whichever way you use is okay. And then the second level is you have a good knowledge of the Java programming language. You know how to use different ways to get the job done. And if there are subtle differences in between them, for example, here we don't save the scanner, so we cannot reuse it after, but it's going to be disposed of, so we are going to economize a little bit of memory, right? Well, you know the difference between the variant. You can use the best variant, kind of optimize your code, use the best variants for the job. That's also the difference between a degree and a certification, okay? Everybody in this room knows what a certification is? Just real quick. So if anybody doesn't know yet what a certification is, talk to me, talk to our faculty. You need to know that for your field, okay? IT and cybersecurity are fields that rely on certifications, right? So it's good to know what they are and maybe pocket one of them before you graduate to add to your resume. The deal is that in this course, for example, I tend to gloss over those little details. What I want is really you to have the capability to think your way through a problem and understand the big concept. If you were to take a certification in Java, that would be the opposite. They would not necessarily test you on the concept and stuff like that, but they would make sure that you know Java, the Java language, inside out. You see the difference? So which one is better? I didn't hear what you answered, but I don't care. because most people are going to take one side, right? They're going to say, well, the concepts are more important. Generally, that would be academics. Or they're going to say, no, the details are important. Generally, this is industry people. The truth in like in most of those dualities is that there is truth in both sides here. Both of them are equally important, actually. If you want to land a job, you need to have the concept, you need to know the problem solving, you need to have this exposure to the general field, okay, that you get through your education. And then if you are going to work in Java or you are going to work in some Microsoft servers product or whatever, you need to know the detail of that tool as well. If you know both, then you are in a better position to get hired than if you only know one. So don't necessarily always choose a camp, right? Consider when you have like a duality like that, what's to gain in both camp. Because most of the time this is just arguing for the sake of arguing. At least in IT and cybersecurity, I would say. All right. So what do we have left here? We are done with that first version, okay? Nothing else to add here. So I uploaded a bunch of files already on the canvas. You're going to see all the steps that I'm following right now in different files so that you can kind of rewind, go forward. The next version that we are going to dig into now is going to be the one where we start writing our own method. So that was pretty much the second half of COP2513. Now I want to break down my code. And yes, I know it sounds silly with a hello word, so bear with me. I want something simple so that we don't spend an hour, explaining some physics or accounting background story that we use to motivate a more realistic problem, okay? So I keep the problem simple, but I still use it to illustrate the tools and mechanics and techniques that we are learning together. So here, for example, how could I possibly break this down? Because it's kind of a simple program, right? So in the slide, I suggested breaking it down in two methods. And why two methods? Just because I need to illustrate different types of method, and two methods is a minimum that I need. So it's more a pedagogical constraint than something, realistic here. So what am I going to break down here? Well, for example, I could say I want a public static method named greet, and that method is going to take as parameter a name, and I'm going to make it do the greeting on the screen. So it's a void method, it doesn't return anything. So bottom line is that I'm not inventing anything. I'm just going to actually take this line here. There we go. And I'm going to move it inside this method. Okay, so I separated two concerns. I separated the first concern, which is pretty much read from the keyboard. Read something from the keyboard, get data from the user, first step. And I could even encapsulate that in a method, right? And then I have another method here that says once you have the name, then greet that user. So I can call here greet with the name. Okay? What's the point? I just added like four lines for what gain? Well, the gain is that the greet method doesn't care about how you get your name. So if I was reading the name from a file, I could still call greet. If I was reading the name from the keyboard, I could call greet. If I was opening a pop-up window, a dialog box on my desktop and asking the user to type something, or reading from a HTML form or something like that, that greet method would still be useful. So this is something that I encountered. I take the time to mention that because I encounter it every semester. Every semester, and we had an example of that, during office hours yesterday. Every semester, I'm going to see many students, if I want to speak English correctly for a change, I'm going to see many students that are actually kind of putting everything together. What I mean by that is they would say in the greet method, for example, they would say, I'm going to read data from the user, I'm going to display on the screen. The truth is that the more specific you are in your code, the less reusable your code is. So we are going to try not to get crazy, right, and make like super abstract methods. But here, greet, it's super clean. It takes a string, it displays it on the screen with some flourishing around it. It does one job, it's a small job, and it does it well. That philosophy of every method, and then later every class should do one thing, do it well, and do a small thing only, is very, very important. Because the more you kind of make your methods and your class atomic in that sense, the more reusable they become. Like the example I just used, now suddenly I don't care where I get the name from. Okay, I'm still getting it from the same, keyboard interaction, but I could change that in the main, and I would never have to touch the greet method. So does it matter here for hello world? No, to be honest. But it's because it's a tiny, very trivial problem. But now, if instead of greet, I have a method that connects to a database, blah, 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 do all sort of things that took me maybe a month to write with a few colleagues, then abstracting away this becomes certainly very valuable. Because it took me a month of my life to get that greet method to work. It's complicated. And now I know how to use it. I can use it in different contexts, in different scenarios. And I don't have to go back into it every time and change it. I don't have to even remember all the details of how I wrote it, during that month, maybe 2 years ago, because I'm going to forget those things. So that's the concept of abstraction. Abstraction comes already with, it's not an object-oriented programming concept. Abstraction comes with writing your method. So we already did abstraction in COP2512. The day that we wrote our first own method, we abstracted some piece of code from the rest. And now we're going to do a lot more of that in this class with object-oriented technique. And you're going to see that it's just the same thing, abstracting, but abstracting with more, and I would say better tools. Okay? At least more complete tools. Let's build it. Oh, surprise, what does it do? John Smith. Hello, John Smith. I am not changing what the code does. Those of you who took COP2512 with me, do you remember what you call it when you change code, hopefully to improve it, but you do not actually change what it does? You just rewrite it differently? Refactoring, yeah. So, and that's not like, this one is not a pedagogical thing. It's actually used in industry. When you get to the point where your code works, generally, you just went through solving a complex problem. You probably can take some time, to rethink it, simplify it, clean it up a little bit, and stuff like that, okay? Or even optimize it, make it run faster. But you have to separate the two tasks. If you try to generate the perfect code, from get-go, generally it ends up pretty badly, pretty poorly, okay? So instead you get it to work, even if it's like holding by little strings inside, and then once it works, once it passes a test, you keep hacking at it again to improve the quality of the code. So you could argue that this is what we did here. We had a hello world that worked, no problem there. We are going to modify it, and now it works, but the greet part is a little bit reusable. So in the files that I uploaded, you're going to see that I went on and what did I do? I did another method. We're going to write it real quick. Public, static. So all my methods are static. Bear with that for now. String get greeting, and then string name. And that one returned something, and it simply returned, this. So that means that now greet was responsible for knowing that I wanted to do a system.out.println, or that I wanted to send that message, into a file, or that I wanted to send it over the network, or insert it with a SQL query into a database. And then it's not responsible anymore for what the message is supposed to look like. So when I want to know what the message is going to look like, I take the name that you gave me, pass it as argument to the method getGreeting, and then this one is going to format and return as a string, how to properly greet whoever has that name. Okay? And that's it. Again, separation of concerns. Okay, what's your name? So it's still doing the same thing. This is refactoring. Okay? Doesn't matter, we're still doing the same job, but now our code gets more and more structure. Last thing that I could do, and I haven't done it actually in the file that I uploaded to Canvas, so we can do that real quick here. I could even abstract this, take it away, and say, I'm going to say string name equal get name. And now the responsibility to figure out where and how to get the name is encapsulated in a method get name that doesn't need any argument. I don't know why I want to put one here. And guess what it does? Nothing new under the sun. It's just going to interact with the console. And then it's going to say string name equal get name. And now the responsibility to figure out where and how to get the name is in a method get name that doesn't need any argument. I don't know why I want to put one here. And guess what it does? Nothing new under the sun. It's just going to ask interact with the console. ask the user for a name, and then return name. Okay? Again, what's your name? Same thing, John Smith. Refactoring. I didn't add any feature. I didn't remove any feature. Okay? But my code is modular. Now I have like several chunks inside of it. And again, for a tiny piece of code, if some of you are thinking this is BS, yes, okay, I would agree to that. I'll give you that. But it's BS only because it's trivial. Now, convert that to a real world problem where you have actually more than one line to write inside each of those methods. Now you are starting reaping the benefit. This is the whole point of object-oriented programming. The whole point of object-oriented programming is you know how to do things like that work on a small scale. But when you try to apply your technique to a larger scale, you are going to sweat it hard. So instead, we're going to learn to do things on a small scale in a better way, using object-oriented programming style. And then when you go and scale up to something a little bit more voluminous, you're going to realize that you don't have as many pains to go through, growing pains. Okay? All right. So this is where we were towards the end of COP2513, right? That was we wrote our own methods. And then at the very end of COP2512, the last version that we actually did is we started splitting things into multiple files, which I already mentioned last time, so I'm going to go fast over this. What do I mean by splitting things over multiple files? Well, here I have my main. So the least I could do is separate the main from what I think is going to be reusable. Okay? So I wrote 3 different methods. I think they are going to be reusable. I hope so. And by the way, one of the things that object-oriented programming is really heavily criticized for is that once you get a taste of object-oriented programming, especially when you just learn to use it as a student, I've done that, you see everything as objects. So you start building like entire hierarchies with many classes, methods, right, left, everything is broken down into a smaller piece. You end up with methods that are only a few lines of code, which is good actually. It's good programming style, but the problem is that there are so many of them that you took a problem that was maybe relatively simple, and just because of your style, you turned it into a nightmare where you have like so many moving parts to connect to one another to get something done that really you could have done very easily. Yes?
So when taking like a lot of usable code used from the main and separating them out and then there as methods, would that reduce the amount of data because the methods would be in the call stack instead of in the main method?
So, okay, so the question, I'm going to kind of like reinterpret it a little bit. Tell me if I go too far, okay? But the question that I'm hearing from you is, when we split this, is there any difference in performance? Is there any difference in terms of memory usage? And yes, actually, there is a little bit of a difference. When you write everything monolithically, you know, everything inside your main, what your application does, it starts and it calls the main, enters the main method, and do its job in there. Now, because I broke down stuff into several methods, it's true that every time I'm calling, for example, greet name here or get name here, what's happening is that I call a new method. So on the program's execution stack that you were mentioning, I'm going to create a new activation record, and I'm going to put some variables in there, like the argument, the parameter, and the local variable. I'm going to transfer the data from the call to the method to actually the inside of the method, run the method, then rewind all of this, right? Remove the activation record when I'm done, return to the main. So yes, there is overhead, okay? There is definitely overhead, and you could say that this is another price to pay. So as everything, you need to, you need to balance out whether it's worth for you to pay that price. Very simple real-life analogy that is also applicable to operating systems, multitasking. Okay, everybody loves to say, I'm good at multitasking. Okay, so let's say that I work on my laptop on a project, and then instead of just alt-tabbing to a different virtual desktop, a different tab, or a different window, let's say that every time I want to check my mail, for example, I have to move sideways here, and I have another laptop to check my mail. And then if I want to check what's up on Discord, I have another laptop here that's connected to Discord. This is actually the next generation of standing desk. right? It's that not only you have a standing desk, but you have several monitors and keyboards that are far, so it forces you to walk back and forth. This has a cost. In operating system parlance, in the internal of an operating system, we call that a context switch. Like you are running on a daily basis, you are running probably 50, 100, 200 processes on your laptop right now, okay? If you had a CPU with one core, there is only one thing that would happen at every second. So how do we make that work? Well, I execute a little bit of that code, like a few milliseconds, then I switch to that one, then I switch to that one, and does it work well? Oh boy, it does work well. It's called multitasking, okay? Every operating system does that. Now they do it even better because the CPUs have multiple cores, so that means that instead of being able to do only one thing at a time, if I have 4 cores, I can do 4 things at a time. So I can repeat that same idea of switching around processes really fast on the first core, the second, the third, and the fourth. And it works very well. Problem with that is that overhead here, if it's small, then I'm okay. If I have a limited number of tasks, I am okay. If I start having too many tasks, or if switching from one task to the other, instead of me going from my laptop, to the next screen here and keyboard to check my mail, okay? Instead of doing that, which is already a lot more work than just alt-tabbing, right? But instead of doing that, I have to go back to my office, go up the stairs, open the door, get in, log into a laptop, open my mail client, check my email, close it, log out, go down the stairs, come back here, then it's going to become untractable. It's going to become something that nobody wants to do. There is too much overhead, okay? So same thing with multitasking. When you are multitasking, there are limits. Multitasking is good. There are limits to multitasking. Same thing with object-oriented programming here and the general idea of breaking down your code into smaller and smaller pieces. Yes, you're going to pay a price, okay? You're going to pay a price. The price is performance versus code reusability. And in the software industry, there is a sort of consensus that, a CPU, I don't know if that's going to continue because there are some events that make the prospect of getting faster CPU may be problematic in the near future. But until now, at least, the idea was, I'm going to get a faster CPU next year, no matter what. And it's going to be like a lot faster. So if you ask me whether I prefer my application to have a little bit of overhead, or I prefer my source code to be harder to read and harder to maintain and harder to debug, I'm going to always favor, the human aspect. I want my programmers to have a good time with the code. I want it to be easy to track down bugs. I want it to be hard to introduce new bugs. All of those have more value than actually a few milliseconds, when you are starting your app. If my app takes 1 second instead of half a second to open, chances are nobody's going to even notice or complain, okay? Except if it's a real-time application like a game or something like that, then it's different. But for most applications, we prefer that kind of trade-off. Okay, so good question. Thank you. All right. Now that I went all the way around, I need to go back to the slide to figure out what I'm going to talk about next. Okay, so yeah, we were about to split this into several files. So I just want to isolate my main. Okay, that's the main thing. So here I'm going to keep that file, and this file is going to have the main, and I'm going to create a new file with a public class. I'm going to call this a greeter, okay? And there we go. And what I'm going to do is first save it. There we go, greeter.java. And I'm going to just go and cut and paste the code that was here. So get name, greet, get greeting, all of this goes into greeter, so that it's reusable, so that it's packaged. Do you need a greeter in your app? Here's my class. Do you need a greeter in your app? Here's my class. Nobody needs a greeter in their app. I'm just wasting my time writing this class. Okay, that happens as well. But the bottom line is, we have units of code that we can now exchange. It's our currency, right? All right, so those methods are still in the class greeter. Sorry, are now in the class greeter. Let me try to compile greeter. Well, it starts complaining about some things like, for example, the scanner. And at this point, I'm thinking, you know what? Do I want actually the get name to be in the greeter, or is it something that would be outside, and the greeter just focuses, on constructing the message. Yeah, these are all design questions. In this class, we don't do object-oriented design. We do object-oriented programming. But there is a whole layer on top of the programming problem, which is, how do I design my classes? What makes sense? What is the most reusable? Okay, what is the best way to organize the code? So for this example here, I'm going to go ahead and say, for example, you know what? I'm going to remove the scanner, because I don't want to deal with the scanner in here. And I have a semi-good reason for that. So, public class greeter, I removed that getName. So, because I removed that getName, I'm going to have to, before I erase it, I'm going to have to take this. There we go. And I'm going to put it back in my main. So, is it compiling now? Yes, it's compiling. Going back to the other file, I don't have the luxury of a getName anymore, but I can do it by hand, or I can have actually, you know what? I can have a public static void getName method here inside this file. So what's happening here? This must be sounding, at least to some of you, I would assume a big part of you, this sounds completely arbitrary. True, design sometimes is arbitrary, but here there is still a logic to my madness. Why did I decide to remove the scanner? Because that class greeter that I want to be able to pass to all my friends, right? I don't know what my friends are doing. Maybe they are doing, again, the example that I use all the time. Maybe they are working with files, working with internet connections, working on a mobile app, working on a desktop app. I don't know how they get data to and from the user. But if I don't care, that means my class is reusable by all those people. So I didn't want to tie up my class greeter to working only with a scanner. Okay? And even more, working only with a scanner that is tied up to the console. That makes it of no interest for most people. Okay? So instead, greeter is a class that's going to encapsulate the logic of building a greeting message and maybe displaying it or returning it. Okay? And then this class here is going to have all the interaction with the user, okay, in terms of scanner, and is going to call the method from the class greeter to construct the greeting and then display it on the screen. Control B. So what's missing here? Incompatible types, void cannot be. Yes, I said getName was void. Here I was going a little too far. String. There we go. So greet cannot find symbol. All right, so this is where we need to be at. So now I split the responsibility between the two files. Okay, one is doing interaction with the user, the other is doing building of the greeting message and stuff like that. And now, when I try to use that greet method, it's still there. It's right here. Okay, I cannot use it anymore. So this is what we finished COP2512 with. These were the last 2 or 3 weeks of COP2512, where we started moving some method and packaging them into their own class. Okay, and these were still static methods. So we haven't introduced yet non-static method. They were still static method. They were still meant to be used the same way. It's just that now I had, every time I wanted to use one of them, I had to prefix it with the name of the class where I put it. And again, I mentioned packages in Java. And I said we are not going to use packages in Java. Instead, we put all of our files in the same folder. So you see greeter.java is here. M1L1 livecoding.java is here. So they're all in the same folder. Because of that, I can just say greeter.greet of name. Okay? And Java is going to be able to find the class greeter, and inside the class greeter is going to be able to find the greet method. If I was spreading my code over different subfolders and stuff like that, I have a whole hierarchy of classes like that organized in packages folder. Think of a package as a folder pretty much, okay? And folders, subfolders, inside folders, etc. Then I would have to do a little bit more work. Maybe I would have to use an import statement. Maybe I would have to write differently the way I call the method. But for this course, I'm just giving you a heads up about, what's going to happen in different, more realistic projects. But for this course, we are going to keep everything together in the same folder so that we don't have to worry too much about this. So here, greeter.greet, did I do the trick? Well, almost, but there's still some problem here. Yes, I forgot to put a return statement. So I'm going to go ahead here and say return name. So that's my getName method. I cut and pasted only a part of it. That's what happened, by the way, with cut and paste programming. You always forget to update something. So this is Joe Smith, the evil twin brother of John Smith, still doing the same thing. Okay, nothing changed again, but now the responsibility of the two different files are clearly delineated. So that means what? That means that if we do that, if we stop doing that with Hello World, because really this is like too simple, but we start applying that principle, to something a little bit more meaty, something like a project where we have some networking involved, some graphic user interface, some whatever, okay, database access. You see the benefit of being able to use the Java language to separate clearly into different files, into different methods, into different classes, the different aspect of the project. It's just so that I don't have to think about all of it all the time, first thing. So even if I am the only programmer in the project, that's going to be useful to me. But even more so than that, okay, if you are working on a project that has millions of lines of code, think about Linux kernel, stuff like that, you simply cannot have a monolithic structure. You have to break it down so that you can have different people work on different parts and have them test their part independently. Okay, and that is the essence of object-oriented programming, pretty much. So we have already abstraction, okay, and this is where we stopped with COP2513. We had a form of abstraction. The one thing that's missing here is that we simplified things and we restricted ourselves to the idea of a class is pretty much a repository of static methods. And we always use static method, even though we didn't know what static methods really are. They were just the only type of method that we were allowed to use. Okay? This is not object-oriented programming yet, even though we use a class. Okay? It's just like a glorified version of procedural programming with a flavor of Java on top of it. But object-oriented programming is going to have us go one step further. What does the step look like? Well, the class greeter, I don't want static methods inside of it anymore. So that's it. I'm removing that static keyword. Big deal, right? So what does that mean now? Well, a static method in a class, you use the keyword static to mark it so that people can call it using the class name. All right. Example of a static method that we all used. math.square-root. You type math.square-root. Math is the name of the class. Dot, I'm going to use a static method inside the class. The name of the method is sqrt, square root, and I pass the argument. This kind of method, it doesn't need objects. It doesn't need an object to work on. All right? Compare this to our friend the scanner. Scanner s equal new scanner system.in. Okay, I created it. S dot nextInt. Who is doing the nextInt? The scanner object that is referenced to by S. Could there be another scanner in the application? Yes. I could have S1, S2, S3, and each of them could execute the nextInt method. Yes. But I choose which one I want to ask to read the next piece of data. Okay? So the idea is when you don't need objects, you just use class names and static method inside. And yes, the class is a repository of static method. Like math, the math class in Java is pretty much that. Most of it is that. Okay? And then sometime you want to be able to create different objects that each follows a pattern that is represented by the class. So you said a class, for example, dog, is supposed to be able to do this, and this, and that. Okay, now I can create a first object. This is my dog. A second object, this is your dog, whatever. And then we are going to have them operate independently. How do we illustrate this with this very trivial example? Well, we do have our method greet and getGreeting that I'm going to now turn into non-static method. Okay? And then, so I'm going to first compile this. There we go. And then I'm going to go to my other file, and the way that I use that class is going to have to change. Static methods in a class, just I can call them very easily with the name of the class and then the name of the method. Here, if I try to compile that, it's going to tell me non-static method greet. Well, yeah, it's true. The greet method is no longer a static method. Cannot be referenced from a static context. So what is a static context? Name of the class dot name of a method. That means I'm thinking this method is static. That's how you call a static method. So this is a static context for the call to the method. Okay. What I'm doing right now, very important, super important. I'm translating compilees. Okay. The speech of the compiler, the language of the compiler. Sometimes it's really understandable. Sometimes not so much, for various reasons that we're not going to get into. Okay. Bottom line is, because sometimes the compiler error messages are obscure and downright confusing, one of the mistakes that some people learning to program do is ignore them. All they get out of the compiler showing an error is a positive, negative reinforcement signal. Okay? No error means, yeah, an error shows up or many errors showed up. It's like somebody tases you in the arm. Okay? That feels bad. But if you don't look at the error message and you don't try to understand it, all you are doing is type some code, bzz, ow. Okay, let me try something different. Type something different, bzz, ah, no, that's not working, and so on and so forth. Okay. Yeah, sometimes that can end up working, but only for small program, and this is really not how you want to learn programming, right? Otherwise, it's going to be a really painful experience. So here, you need to look at the compiler error message, and a very good thing to do with a compiler error message is to paste it on Piazza, or bring your laptop, to office hours, whatever, and show a TA or myself, hey, this is what I'm getting. I have no idea what the compiler wants. And progressively, we're going to help you understand how the compiler notifies you of certain classes of error. Okay? There will be no point in having a giant 15-hour long lecture where we go every single compiler error message. There are just too many of them. But you are going to have to learn as you practice, to get kind of immunized to the error message as the compiler can present you with, and we're going to help you do that. But really, do not ignore the meaning of the message. Do not just get out of this that something is not working. So, how do I change that? Well, it's complaining about the static context. So, I use the static context to call a static method. It kind of makes sense that if I call a non-static method, I should use a non-static context. I'm willing to go with that even if I don't understand all the details yet about static methods and stuff like that. So what would be a non-static context? Well, if static means I call the method on the class itself, in object-oriented programming, the only other alternative that I have is calling a method on an object. Again, remember scanner S and then S.nextIt. There we go. That's what we're talking about. So how do I create an object of class greeter? Again, scanner S equal new scanner. If I can type, there we go. So I'm going to use that as a template. Greeter G equal new greeter. And I don't need to put anything in parentheses here. And we are going to talk about that next lecture when we deal with constructors, okay? But right now, I can create a new object of the class greeter. So what does that mean to create an object of a class? That means I'm going to go look at the code for the class. It's going to tell me exactly what every object of that class should be able to do. And I use that as a cookie cutter, as a template. And here we go. I create in memory an object. And I put the reference to that object in the variable G. And now I can access that object using G dot. And then I tell the object whatever I want it to do. So here, g.greet of name. Let's try to compile. It's compiling. What's your name? John something. Hello, John something. Again, refactoring. Okay. So what is the big difference now between this and the previous version? Because we still have the same two files, we still have the same split really of responsibilities. Okay. Well, this would become useful if I was not to have only one greeter in my application, but many greeters, okay? And I'm going to anticipate a little bit on what we're going to cover next session, but that's going to give you some exposure, and then by the time we cover it next session, it's going to make sense. What if I wanted to say, I want a greeter G that says hello, and sometime I want a greeter GG that says hi. So this is independent of the name. right? Okay, I haven't read the name yet, I don't care. I'm just like saying that I want two different ways to greet somebody. One that is more formal maybe than the other, I don't know. Not really actually, but gg.greet name. So I want to be able to have different objects of the class greeter that are differentiated from one another based on what greeting message I want to use. So this is where I'm going to anticipate a little bit the syntax we're going to talk about next time, okay? But I'm going to go here and I'm going to say, okay, every object of class greeter is not the same. So I need a way, once the object is created in memory, to kind of like, go inside of it and tune it, parameterize it. So this is called a constructor. So public greeter, and yes, I didn't forget the void. That's actually how it works. The greeting here is going to be what I pass as parameter. And what I want to do here is, for example, my greeting equal greeting. And my greeting is going to be, again, a new thing that we're going to explore in detail next lecture. It's going to be an attribute of the class, which means that every single object of class greeter is going to have inside of it, think of it as a variable, okay, called my greeting, and that my greeting is going to be initialized when we create the object by passing something to it, by telling it, hey, I want you to be a greeter object. But I want you to be the kind of greeter object that says hello. I want you to be the kind of greeter object that says hi, and so on and so forth. Okay? So we need to modify a few more things here. So I want to use that greeting. So instead of saying always hello here, I want to go right here and say my greeting plus the comma plus the name. So what does that mean? That means that when I run the method getGreeting, okay, then each object is going to check, by the way, which type of greeting am I supposed to use? It's going to check that attribute, concatenate it, then it's going to say, okay, what is the name of the person I need to greet? This is a parameter you give me, concatenate it, and so on and so forth. Control B, Control R, so that one I cannot run, oops, sorry about that. Go here, Control B again, Control R, what's your name? John Smith. Hello, John Smith. Hi, John Smith. Okay? All right. We are going to stop here for today. Next lecture, we're going to go more into the detail of this. Please do not show anybody that you did 5 different versions of Hello World today in a class at college level. Just kidding. But it's just that this is a very simple example. We are going to apply that to more complex stuff. Believe me. All right. Thank you. Yes. I'm sorry, what? Can I see your greeter file? Yes, absolutely. Let me make this bigger. There we go. And while you take a look, I'm going to stop the recording in the background.